Okay, in this video I'm having a look at this revision sheet for grade 9. So going through each of the questions and having a look at how we answer them. So the first question says state the gradient and the y-intercept for the following linear equations, and then note whether the gradient is positive, negative, 0 or undefined. So for the first one we've got y equals 5x minus 6. So our gradient is going to be 5. And our y-intercept is going to be negative 6. Now we want to then say whether the gradient is positive, negative, 0 or undefined. So in this case our gradient is 5, so that makes it positive. And then we have, let's realise that one is just off screen a little bit, so I'll bring that over. The next one we've got is y equals negative 2x minus 4. So my m is negative 2. And my c is negative 4. And then if I'm looking at that gradient, it's got a negative gradient. The next one's a little bit different because we don't have it in the form of y equals mx plus c. So we need to rearrange it first. So if I add y to the other side, that'll leave me with x plus 6 equals y. Now I can rewrite that as y equals x plus 6 by just putting it the other way around. And then I can see that my gradient, because there's nothing in front of the x, that means it's a 1. So my m is equal to 1. And my y-intercept is equal to 6. Now for part D, we've got a special line here, x equals negative 6. So that means it is going to be parallel to the y-axis. So if we did a little sketch down here of what that would look like, and we've got x equals negative 6. Here's negative 6 over here, 0. Positive 6, we have got our vertical line there that gives us x equals negative 6. Now we know vertical lines have a gradient of where it's undefined. We can also see that it's not going to have a y-intercept, it's not cutting through the y-axis. And so when we're talking about our gradient being positive, negative, 0, undefined, it's undefined. Our last one, y equals 4, that's a horizontal line going through y equals 4. So it has a gradient of 0, so its m is equal to 0, and its c is equal to 4. So then when we describe our gradient being positive, negative, 0, undefined, it's 0. In question 2, we're looking at some simplifying, leaving our answer with positive indices. So we're looking at our index laws type questions. So our first one we've got is 9x squared, and then we've got xy cubed to the power of 2. So the first bit I'm going to do is I'll keep my 9x squared there, but I'm going to focus on that bracket. So because the 2 is there, that's going to apply to the x, and it's also going to apply to the y. So we'll end up with x squared and y to the power of 6, because 3 times 2 is 6. Then I can simplify my x squared times x squared and just make that x to the power of 4, y to the power of 6. For b, I'm going to do the apply that power of 3 first, and then I will multiply by 3. So that means I've got my 3 at the front still, and then 4 to the 3. X will become to the 6 because it's got a 2. The y will become to the 15 because 5 times 3 is 15, and then my z is to the power of 3. Then I can just simply take that bracket away. I can work out my 4 to the power of 3. So 4 to the power of 3 is 64, and I'm timesing that by 3. So I can write that as 192, and then I'll leave the other terms as they are. I could also have left that as 3 times 4 to the power of 3 and left it in the index form there. For part C, we've got 9x squared y to the power of 3 times 4xy over 3x squared y. So I want to simplify what's on the top first. So I've got 9 times 4 is 36. Then I've got x squared and x, so that'll be x to the power of 3. Then I've got y cubed and y, so that'll be y to the power of 4, and that's over 3x squared y. Now I'm going to look at my numbers, and I've got 36 divided by 3, so I know that's 12. I've got x to the power of 3 on the top and x squared on the bottom. So overall 3 take 2 is 1, so that'll leave me with an x. And then I've got y to the 4 and y to the 1 there. 4 take 1 is y to the power of 3. Going on to D, we've got 5 to the power of 3 times 5 to the power of 2. I'm just going to fit that one in right here and write that as 5 to the power of 5. Then I've got down here one that's a little bit trickier because we need to break down some of these ones that we've got here. So getting a fresh piece of paper, I've got 8 squared. Now I know that 8 is 2 times 2 times 2, which is 2 cubed. So this is quite a tricky question. So we've got 2 cubed and it's being raised to a square. We call this powers of prime. Then we've got 2 to the power of 4. Then we've got times 3 squared, and then we've got times 27 squared. But I know that 27 is 3 to the power of 3 because 3 times 3 is 9, times 3 is 27. So I write 3 to the power of 3, and I'm going to raise that to a power of 2. Now I need to simplify these ones with the brackets. So 2 to the power of 3, when it's raised to the power of 2, will be 2 to the 6. My 2 to the 4 stays the same, my 3 to the 2 stays the same, and then this 3 to the power of 3 being raised to a 2 will be 3 to the 6. I can then bring together the ones with the same base. So 2 to the 6 times 2 to the 4 will just be 2 to the power of 10. And 3 to the power of 2 times 3 to the power of 6 will be 3 to the power of 8. So that one is that one finished off. Then we go to F, where we've got E's and A's in our division, like a fraction there. So I'm going to simplify the top first. So I've got 10e to the power of 6 times 2 a to the power of 3. I can do my negative 10 times 2 is negative 20, and then I've got e to the 6, a to the 3. On the bottom, I've got negative 5, and then I've got an e, and I've got an a times a squared, which will be a to the power of 3. So I can cancel the a to the power of 3 on the top and on the bottom of that fraction. With my e to the 6, I can do the 6 take 1, which will leave me with e to the 5, and then negative 20 divided by negative 5 is just going to be 4. So my answer is 4e to the power of 5. Then I've got one with multiply and divide in it. So I'm going to focus on the multiply first. So I've got negative 3x squared, and I'm multiplying that by 2y to the power of 7. So that gives me negative 6x squared y to the 7, and it's being divided by negative 2x to the power of 5. So I know that negative 6 divided by negative 2 is going to be positive 3. Then I've got more x's on the bottom, so I'm going to leave them on the bottom and do the 5 take 2 is x to the power of 3, and then my y to the power of 7 remains the same. Then the last one I'm going to do in this video is this 1 over x to the negative 3. I want to have positive indices, so all I need to do is bring that up to the top of the fraction and write that as x to the power of 3. So that one was a nice easy one to finish off that set. In the next video, I'm going to start at question 3 and keep working through.